Hello 7th graders, and welcome to another day of review, where today we're going to review the concept of plate motion. In this unit, we really only had to learn two specific things. The first being, why do earthquakes happen? Where we realize that plates, or large section of the outer layer of the earth, crash together when they move to create enormous seismic activity, so when the earth shakes. And the second one was, why fossils are so separated, even though they're so similar. The example we got in class was the Mesosaurus fossil. The Mesosaurus fossil is shaped very much like a crocodile, but a lot bigger. What's really perplexing, or really mysterious to scientists, is that this fossil is very similar to the fossils found in South Africa and South America. These two similar fossils, it turned out, were actually not just similar, but the exact same fossil from the exact same time period. But this animal, this Mesosaurus, this large crocodile, couldn't possibly have swam from Africa to South America. So scientists asked the question, how did they get so separated in the first place? In order to do that, we had to learn about plate tectonics. Plate tectonics says that the Earth's outermost layer, the crust, floats on top of the mantle. In the same way a piece of wood would float on water, the crust floats on the mantle. And in the same way a piece of wood will move around in the water as it flows and moves, the crust moves along with the mantle. Satellites tell scientists that plates move at a rate of about 3 centimeters a year. If you want to know what that space looks like, it's about the space between your thumb and your pinky. It's not that far for a year. Next, scientists had to ask the question, if the plates are moving, how is it that South America and Africa got separated? The answer is that there are boundaries between plates, or places where plates meet, where they're pulled apart. And we know this because scientists were able to discover that magma rises between these plates, and when it fills those gaps, the water instantly cools it into new rock, which means the rock near the plate boundary is younger than the rocks on the other side, because as they move apart, new rocks get added and older rocks are moved to the sides. This was a remarkable discovery for scientists as it helped prove the theory of plate tectonics, the reason why earthquakes happen. More importantly than that, however, in the case of our fossils, it proved why they were so far apart. South America and Africa once shared a plate boundary when they were closer together, millions of years ago when the Mesosaurus was alive, and then over time they separated, and the fossils that were on their shores got separated too. There was one other kind of plate boundary scientists discovered while looking into this, and that was the convergent boundary. Where the divergent boundaries diverge or pull apart, the convergent boundaries converge or come together. You can see in this diagram how the lithosphere, or the crust, and the extensosphere, which is just the upper part of the mantle, are pushed under a heavier plate on the side when they converge. Being pushed together like this creates friction and makes heat, which is why part of the material that is here melts, turns into lava, and the hot lava rises to the surface, where these slightly higher rocks, which we call mountains, are turning into a volcano. One of the major issues for scientists was finding a way to prove that plate tectonics was true. In order to do that, they had to use three major pieces of evidence. In fact, the Mesosaurus fossil was the first one they really discovered that got them asking these questions, because it's not the only fossil that's separated by such a large distance, despite being from the same time period. The second piece of evidence they found had to do with the way the plates are shaped together, in particular the way the continents are shaped together. You can see the shape of Africa here and South America, where they share this border where the Mesosaurus might have lived, and it pulled apart over time to form more small land masses. The last piece of evidence is called seafloor spreading, which we talked about earlier, where younger rocks are near the middle of the ridge or the middle of the boundary and older rocks are to the sides. This could only happen if they're being pulled apart because where they're made new is the start position and later they're older. Alright, you should have enough information to get started on doing the worksheet. If you have any questions, you can always text me, ask a question in the Google Classroom, or get me at my Zoom office hours from 12 to 1.